Hi there. Let's name some of the organic compounds. So we are given 2-ethylhexanitrile. So what you want to do first, put the number of carbons. It's hexane, 6 carbons in a row, and also you can number from any direction because we are just drawing it. So hexane is 6 carbon, 1, 2, 3, 4, 5, 6, 6, and either side is fine. But now we already have put the numbers. Now we're going to put where the nitrile is. That's the functional group. Nitrile is C triple bond N. Now we call cyano when it is a substituent. In this case, this is the major, so it would be C triple bond N. It's a nitrile, but it should be in the number 1 carbon, right? So either we have to change the numbering or let's switch the CN into the front side. Yeah, so that would work. So yes, so nitrile group in the first carbon that is included that carbon, and then you have a 2-ethyl. So ethyl is 2 carbons, so stick it into the second carbon ethyl group. That's it. So we can redraw in another way, and sometimes you're going to see, so the picture to name drawing, it might looks like this. So, and also notice that the triple bond is 180 degrees. It's sp hybridization, and second carbon is attached with the ethyl group. So that's that, right? So let's try to draw 4-chloro, 3-octanone. So that's octan, 8 carbons. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Now let's put the numbers from any side up to 8. Now we are good. So now we know the functional group has priority. That's because anytime it's a 3-octanone, right? So third carbon has a double bond O, ketone group. Now just remember, anytime when you have double bond oxygens, they get priority actually, right? Now the chloro group is at the 4th carbon. Just stick it there, and then that's it. So we can redraw it, and so it could be twisted in a picture to name situation. It could be something like that, and even even twist around, but still the long chain carbon is 8 carbons, right? Then all we need is to put the double bond O, which is ketone group, at the 3rd carbon, and at the 4th carbon there should be chloro in this case, right? So the long chain is anyway, it's continuous long chain carbon, that is 8 carbons. That's the key thing. Okay, now also just notice every carbon has 4 bonds, and these are all alkanes. That's why they are naming ending with ANE. So let's look at this one. 5-bromo 2-hexanol. So 6 carbons, 1, 2, 3, 4, 5, 6, and from any side because we are drawing it, right? And then 2-hexanol, second position has to be a OH. It's an alcohol group, the hydroxy, so that has to be at the 2nd carbon. Now 2-hexanol is done. We need to find the 5 and stick a bromo atom there, right? So number 5 carbon should have a bromine. Okay, so that's that 5-bromo 2-hexanol, right? Now also notice again, so in case you should know there are 4 bonds for each carbon when it is single bonded sp3, then there should be hydrogens filled if needed. But typically we use the line diagrams, right? Ethoxy ethane, this is a little bit of a tricky one. Ethoxy ethane. But the name kind of tells you ethane means you draw a 2-carbon unit. So that's where you start. Always you start with, I call the last name. That's actually the root name, right? So 2 carbons because that's the longest chain. That's why. Now there's ethoxy. Ethoxy means RO, right? It could be methoxy, ethoxy, propoxy, and so on. But in this case, O and 2-carbon unit. So you need 2 carbons and an oxygen. Then they should be linked. It should look like. So this one is kind of ugly. Let's draw it like the way you have seen it in books. This is the way it should be seen. So this is actually diethyl ether. That's the normal name we use, diethyl ether. Sometimes in my organic laboratories, I call it DEE, diethyl ether, because we don't say all the time diethyl ether. We just say DE, right? So that's that. Now also ethoxy ethane, it could be methoxy ethane, it could be um, ethoxy butane, and so on. So you can name the ethers like that. Also the symbol is ROR. Remember that way. So R, so the ethers are typical symbol of ROR. So the carbon, oxygen, carbon. That's how it goes. So butanamine, it's an easier one. So butane is 4 carbons, amine is a NH2. So you put 4 carbons number from any side, and then you need a NH2. Amine is a NH2. Anytime when you see amine related, think of ammonia, NH3, then you go from there actually, right? So you can start with that NH2 and then stick 4 carbons out, and that would be it. Now the number 1 carbon attached to the nitrogen atom. That's for the butanamine. So we might need, yeah, so this one is, yeah, triethylamine. It's not an IUPAC name, right? The actual IPAC name. So for the amines, actually, most of the university classes and most of the classes, you are not using the IPAC naming. But this one, the symbol is RNH2. It's generated from the ammonia. So you cut through, you cross out hydrogens and you put R groups. You can put up to 4 actually, because ammonium salts have 4 R groups. Okay, this one. So triethylamine, you start with ammonia, right, NH3, and then um, cut and remove hydrogens and add R groups. In this case, ethyl R group. So you put 2 carbons onto each hydrogen because it's triethyl, and cross it out. So not memorization, just try to build it with the logic, right? That should look like this actually. So in a question, if your professor drawing the question, he might draw the green one from on your right, and you're trying to label it. So it's triethylamine. And IUPAC naming, actually it's N triethylamine, because you say where the ethyls are attached, there it's attached to nitrogen. That's what it is. Okay. Number 7. So now you're given the structure you're trying to name. Now we're going to change the game plan. So first we're going to find out the priority, the function. That's aldehyde. When you have double bond O and a H, it's an aldehyde. Also remember, when you have double bond O, they have priority actually. So single bond also valid. Now, numbering number 1, 2, 3, 4, 5, 6, or we can go right or left, but we see the right doesn't go that far, so we go to left. But number 1 always the L carbon, the aldehyde carbon. That's important. Now we can, so it would be 6 is hexane and aldehyde is L, it's hexanal. So one hexanal you don't say, and then you have methyl group at sitting on the third carbon. So it should be 3 methyl. Now, so we are not done yet, because you see the right side wing, the 3 and 4 that I crossed it out. There are 2 carbon unit, which is ethyl attached to the second carbon. So we should say second dash ethyl, because ethyl comes before methyl because of the alphabetical order, right? So watch my previous video. I put the 4 kind of rules. So it's a actually shortcut, but you can use it. Now, let's look at number 8. Again, a structure line diagram, and then we're going to find out the functional group first for the priority, and that's for numbering actually. I mean, kind of the order is functional group, no long chains, finding out, and then the subs. So 1 is carboxylic, 2, 3, 4, 5, 6. That's going to the left again, not to the right, because right is only 2 carbons, right? Now we can label it. So because it's oic acid, so 6 carbon chain, long chain hexanoic acid. Now we can label the substituent, this one, 2 carbon unit ethyl sitting on second carbon. Now this one, the fourth carbon has 2 methyl groups attached. These are also substituents, right? So let's label 2 ethyl and then 4,4 dimethyl. So 4,4, just to show each methyl is attached to a fourth position, because each substituent has its position. So that's why it's 2 ethyl 4,4 dimethyl. Each methyl is attached to 4. That's what it is. Okay. Now we go to the this one is much simpler one, I think. So functionality group, functionality, identify that one. It is an one ketone, and its ketone could be anywhere in the carbon chain, but we can number from left to the right, right to the left. But we know functional group has the priority, so it gets number 2. It's not number 1 because it's in the middle of a chain, right? So then we have 9 carbons. It's nonane, so nonan 2 on, or you can say 2 nonon, nonan on, right? And yes, it's hard to say. Now, um, the substituent is 8 methyl, and that's all actually, right? Because number 1 is not a sub, it's just part of the main chain, but your functional group is sitting on the second carbon. That's the specialty. The ketones normally not never number 1, but it would be 2 3, something like that. So let's look at this long chain hydrocarbon again. Nothing else there, so let's see whether anything. No, nothing else there. So we can number 1 2 3 from left to the right, right to the left. But you see, you're looking for in the when you select the longest chain, you should also select the earliest branching growing from right to the left. So therefore 1 to 9, it's a nonan or nonane, nothing else there. It's an alkane. So the alkanes are anes, ANE, sp3, CnH2n plus 2. The generic formula for the homologous series, CnH2n plus 2. All are single bonds. It's common name alkane. You name as ethane, methane, propane, butane, and so. Okay. So number 7 carbon has a substituent. Number 3 carbon has a substituent. Number 2 has 2 substituents. All are methyls. So kind of I circle them just to identify easily. So it's a tetramethyl. Now you have to say each methyl is where. So 2 2 and 3 7 dash, because there's methyl groups at the second position, and then and so on. Okay, let's jump to the next one. So another long chain carbon. So you have to label for the earliest branching from left to the right. So we have it, it's 10. So it's a decane, it's an alkane, 10 carbons, decane, and it can go on, but that's good enough for us, right? Now here, on the 6th carbon, methyl is sitting. On the 5th carbon, ethyl is sitting. So that should be, the substituents are 5-ethyl, 6-methyl, decane. So it should be one name. So I kind of separate them for easy reading, but it's one name actually, right? One word. Okay. And there are numbers and hyphens in the middle. Look at this one. The functional group is carboxylic, and it's an oic acid, and number 1 is there. Now we choose the longest chain including that number 1, so it goes left. It's 6 carbons, hexanoic, we can call hexanoic acid, and second carbon has a methyl substituent, so it's 2-methyl hexanoic acid. Now look at number 13. So you can number from each side, but you want to number from left to the right because earliest branching is left to the right. So let's put the numbers 1, 2, 3, 4, 5, 6, 7, 8. So it's octane, and then second carbon is branching. That's the point. That's why we counted that way, numbered that way. So octane, it's an alkane. And you have ethyl group at the 5th, methyl at 4th, methyl at 2nd. So 5-ethyl comes to the front because of the alphabetical order. So 5-ethyl dash 2,4-dimethyl. So each methyl is sitting on second and fourth carbon on the main chain. So that's why 2,4-dimethyl. So now also just remember, if you have substituents, 3 is tri, 4 is tetra, 5 is penta, and 6 is hexa, and so on. You can go on, right? So those are for substituents to show the superlatives. So I think this is the last question here. Yes. So let's see. So long chain, earliest branching goes from left to the right, 1 to 9. So it's a nonane, it's an alkane. No other functionalities, nothing there. So now the substituents, ethyl group sitting on 5th, ethyl group sitting on 4th. So that should be labeled as diethyl, right? So, but we have to say the numbers for 4, 5 dash diethyl nonane, one word. That's it. Thank you.